In this video, we're going to learn how to solve these JAMB Maths questions under significant figures. So these are repeated questions we're going to practice with. So let's begin with this first one we have here. We're asked to evaluate this and correct to 4 significant figures. So let's get a calculator and simplify this. So this is the JAMB calculator. We have the numerator 0.21, alright, times 0.072, okay, times 0.00054. Alright, so it's giving out this value in this output. Now for you guys not to get confused, let's just do this manually so that we get a definite value. So let's just solve it manually. Now if you want to solve this manually, basically this is going to be, if you are simplifying the numerator, this is going to be 0.21 is something as 2.1 times 10 to the power negative 1. Alright, remember we have done standard form 0.21. This will take this once, so it will now be 2.1 times 10 to the power minus 1. Okay, times we have this 0.072 is something as 7.2 times 10 to the power minus 2 times now 0.00054 is something as 5.4 times 10 raised to power, you move 1 2 3 4 up to 4 times, okay, over, then we have this one give you 6.0 times 0.006 something as 6.0 times 10 to the power negative 3 times 1.68, okay, times 6.3 times 10 to the power negative 2. Alright, now if you want to break this down, we are going to apply a lot of indices, which states that when you are dealing with values and the base is the same, when it involves multiplication, the base is the same, you add the powers. So let's add the powers at the numerator. So it's going to be 2.1 times 7.2 times 5.4 times 10 to the power. So we have minus 1 plus minus 2, that's minus 3. Everything here will give us minus 7, okay, over, we now have, this will give us 6.0 times 1.68 times 6.3 times, now minus 3 plus minus 2 give us times 10 to the power minus 5. Alright, now you still apply the law of indices again. The law of indices, which states that this time we have division, when the base is the same and is dividing, you subtract the powers. So this thing will be the same thing as 2.1 times 7.2 times 5.4 times, now the base is the same. This is going to give us 10 to the power. This time I want it to be minus 7 minus minus 5. So minus 7 minus minus 5, minus times minus is plus, so it's going to be minus 7 plus 5. So minus 7 plus 5 give us minus 2, okay, over, we have 6.0 times 1.68 times 6.3. So let's break it down now with this calculator and see what it's going to give us. So let's release what we have here. This time around we have 2.1, okay, times 7.2, okay, times 5.4 times, now 10 to the power negative 2 is something as 0.01, okay. So this one now we can express 10 to the power negative 2. So let's press support and see the outputs. We have, let's write it down. So we have it to be 0.81648, okay, this is 0 guys, divide, so let's check the denominator. Let's simplify the denominator. So for the denominator, we have 6.0 times 1.68, okay, times 6.3. What's the output? So we have it to be 63.504. So this is over, just write it down, 63.504. So at this juncture, let's do everything together on this calculator. So we have 0.81648 divide 63.504. So what's the output? So we have it to be this 0.012857. So let's write it down. So we have it to be 0.01285714. We also round up to 4 significant figures. So significant values start from non-zero number. So this is significant, this one significant, this 2 significant, this 8 significant, this 5 significant, this 7 significant. So the first significant figure here is 1, second is 2, the third is 8, the fourth is this 5 we have here. So to fourth significant figure, this 7 after 5 is up to 5. Alright, so you round it up as 1, put it here. This 5 now change to 6. So the final result for this question will be 0.01286, and this will be the answer to this question. So it's as easy as this. So that's it for this question. Now let's wipe this and solve the next question. Alright, now for the next question, let's go to the next question. We are given this, I'll simplify to 3 significant figures. So let's simplify the numerator. We have it to be 0.0324, okay, times 4.921. So what's the output? We have it to be this value. Okay, so let's write it down so that we not get unnecessary error. So we have 0.1594404. This is point. Okay, then let's check the denominator. What will be the output? So we have 1.2, okay, times 3.43. So what is going to give us? We have it to be 4.116, okay, 4.116. So let's delete everything here. So it will now be 0.1594404 divide 4.116. So what's the output? We have it to be 0.03873,673. So to 3 significant figure, this one is significant, this one is significant, this one is significant. This is the 3 significant figure. After 7 we have 3, the fourth one. This 3 is not up to 5, so you can't round it off. So basically the answer to this question will be 0.0387, which is option D. Alright, so we are making progress. Let's wipe this and solve the next question. So next question I have here is this. We have to simplify this to 2 significant figures. Remember, we are solving repeated questions under significant figure for your JAMB Maths. So we have this one is 0.0839, alright, times 6.381. So what's the output? We have it to be this. So you can divide it by what we have at the denominator, 5.44. So check the output. We have it to be this. So you write it down. So we have 0.09841285 to 2 significant figures. This one is significant, this one is significant. So this 4 after 8, which is the third value, is not up to 5. So basically the answer to this question will be 0.098. Okay, so the correct option is what? Option C. Okay, so let's wipe this and solve the next question. This is going to be the fourth question we're going to solve. So in this question, we have to express this value to three significant figures. So we have 123,456. Now, in this value, all the values we have here, the numbers we have here, all of them are significant. 1 is significant, 2 is significant, 3 is significant, 4, 5, and 6, they are all significant. So to three significant figure, this is the first one, second one, third one. The fourth one, which is the four we have here, is not up to 5. So basically, now I want to show you guys something. Let me just write this down. This question is peculiar. Let me show you something. Okay, so every value here is significant, so we have to keep it to three significant figures. This 4 is not up to 5, so basically the answer to this question will be 1, 2, 3. Now when you are dealing with significant values before the decimal point, like this value we have, there is no point to it. So now that we have rounded up to three significant figure, the other remaining values will be replaced as 0, so it will now be 1, 2, 3, 0, 0, 0. All right, if we are asked to round it up to 5 significant figure, it will be 1, 2, 3, 4, 6. This is up to 5. Take it out and put in this 5. This 5 now be 6, 0. Okay, so in this order. So adibin, this question is having points, let's say 0.76, and you have to round it off to three significant figure. If you have to round this value to three significant figure, it will still be this. Okay, the answer will still be this. But when you go beyond the decimal point, let me say this question now is having points, and you have to round it off to 7 significant figure. This would have been, with this condition, this would have been 1, 2, 3, 4, 5, 6.8. This is the seventh one. This is up to 5. Put it here, it will now be 8. You will not put any 0 after the decimal point, but before the decimal point you are going to put 0. Alright, so that's what I basically want to explain. Alright, so that's it for this kind of question. So let's wipe this and solve the next question. So next question we have is question number D. So we have to express this in three significant figure. So we're going to simplify this. It's going to give you 81. So let's remove everything here. So it's going to be 81.81 plus 99.44. Let's check the output. So this is the output. We have it to be 181.25. So let's take what we have as the denominator. So it's going to be 20.09 plus 36.16. So we have it to be 56.25. 56.25. So at this juncture you can put everything together. So we have 181.25 divided by 56.25. So we have it to be this value. We have to leave it to three significant figure. So the three significant figure, the answer will be 3.222. The answer will be rather 3.22, because every value here is significant. So the correct option in this question will be option C. It will be 3.22. Alright, so that's it for this question. Let's wipe this and look at the next question. Okay, so next question we have here, we have to evaluate this to three significant figures. This question is very cheap. So that's 21 divide 9. So we have it to be 2.33333. So to three significant figure, It's going to give us 2.3. Every value here is significant, so it's going to be 2.33. The correct option is still what? Option C. Alright, so that's it for this question. Lastly, let's look at this question. Alright, so let's look at this last question. It says, give the number of significant figures of the population of a town which has approximately 5,020,700 people. Now guys, I want to explain something critical here. This question, looking at it, might look easy, but if you're not careful, you easily fail it. Now I want to explain something very, very important here. Okay, just pay attention guys. Now, when 0 is in between non-significant values, such 0, for instance, so when you have something like 1001, these two 0 values are in between non-zero number 1 and 1, so they will be counted as significant. Alright, when 0 is after a non-zero number, for instance, if you have something like 500, these two 0 values after 5, they are not significant, but there is a point here, these zeros would have been significant, but since there is no point, just 500, we have only one significant figure here, which is the 5. The same thing that is applicable to what we have here as a question. Okay, so these two zeros are in between non-zero values 5 and 7. So basically, this is significant, this is significant, this is significant, this is significant, this is significant. These two last zeros are not significant, so they will not be counted. So basically, how many significant figures do we have here? We have 1, 2, 3, 4, 5. So 5 significant figures. So the correct option in this question is option B and not option C. Is not, we don't have 7 significant figures here, rather we have 5. Alright, very, very important. Assuming this question is having point attached to it, it would have been 7 significant figures, but since there is no point attached to it, we have 5 significant figures. These last two 0 values are not significant. Okay, so hope is understood. This is basically how you can deal with problems involving significant figures for your JAMB Maths. These are repeated questions, or there are chances that a good number of them might come out for you again in this year's JAMB Maths. So let's go to the video guys. Hope you learned something interesting from this video. Let's go to the video. If you are new to the channel, ensure that you subscribe to this channel by hitting the subscribe button for more of these videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave your question at the comment section below and I'll be sure to give you a response. Alright, now click on the end screen above and I'll see you in the next video. Thanks for watching.